saying this is region A, this is region B, this is region C, and this is region D. Alright, so we're going to use any point to test these different regions to see which one works. Let's use point 0, 5, so that's going to be up here, to test for region A. So we're just going to plug in this point into our equations. If we plug it into the first equation, we're going to get x is 0, so that just gets canceled out. 5 is greater than negative 4. That's true. Put it in the second equation. 0, 0, negative 1. 5 is greater than negative 1. True. So then, because those are both true, then we know that region A is where we need to shade in. Alright, so for these problems, we're just going to split our graph into different regions and then use test points to figure out where it needs to be shaded. Alright, now we're going to talk about exponential equations. Alright, so exponential equations, we know that 10 squared equals 100, right? And so if we say 10 squared is equal to 10x, we know 2 is equal to x, right? So two exponents with the same base are going to be equal. So we can use our knowledge of logarithms and this knowledge of exponents to solve something like this. Alright, so we'll put 17 in base 10. So we're going to get log 17 is 1.23. So that means that 10 to the 1.23 is equal to 17. So we can put that in our equation right here. And because these two exponents have the same base, we can say they are equal. And we can solve for x. Alright. Now exponential functions showing growth. Alright. So we have equations like this showing exponential growth. Alright. So if we have two equations like this, showing growth in terms of time. When t is 0, then this is going to be 0. So they both start at the same place. Our a0, so to speak, is going to be equal. Now this equation is going to be at the 0.2 growth, and this one's at the 0.4 growth. And that's how we see our different exponential growth.